Ladies and gentlemen, hello and welcome, coming to you again, not quite live from One Take Studios, where today we are talking about graphing quadratic functions, and we're going to additionally talk about transformations and how that might affect the graph as well, because those are kind of neat things to see. Alright, so for starters, I want to introduce standard form for quadratic equation, in case you haven't seen that. So standard form is the ax squared plus bx plus c. Many equations have a standard form, and you usually find them alphabetical. A is with the highest power, and then B is with the second highest power, and so on and so forth. Now, I like to call this the formal form. It's often not super useful just by looking at it. It doesn't tell us anything really obvious, usually. But it's a great form if you would like to do quadratics and have tea with the queen at the same time. So this is our formal setting for things. It is a form that you should know, and I'm going to decorate it in red squigglies because, ladies and gentlemen, this is a party zone. It deserves a party, something to make it not get lost in our notes. So standard form, f of x equals ax squared plus bx plus c. Alright, so I have an example here. I've got f of x equals negative x squared plus 3x minus 2. And I want to look at what it would take to graph that, what that would look like. And so, consequently, I have some beautiful graph paper here. By the way, these are graph stickers. If you have no graph stickers in your life, I'm very sorry for you. Everybody should have graph stickers. Let's borrow our calculator and use it to help us start the thinking process. So, here's my calculator. I have it set up, ready to go, and there we go. And I've already got it typed in, so negative x squared plus 3x minus 2. You want to make sure that you are on a graphing screen. I'm on my scratch pad right now with the graphing. And the negative sign is here. Be careful, that's different from the subtraction sign, so this is my negative sign. And x squared is right over here. So I've got it typed in. If you decide to graph and this box doesn't show up at first, hit the tab key, and the tab key will always bring you your graphing box, so you can type in an equation. If I hit enter, I get something beautiful and gorgeous and lovely and... Well, now wait a minute. I'm going to move this just to clarify things a little bit. You also can move yours if you'd like. With this, how would I know that this particular equation would end up looking like this? Well, okay. We're talking about these being quadratic equations. X squared is always a quadratic if x squared is the highest power. That really messes with people's minds, though. X squared is quadratic? I mean, quad. Quad means 4. How do we get... Oh, x squared. Square. What does a square have? A square has 4 sides. Think of the shape. Ladies and gentlemen, x squared represents a square, like in concept-wise, and therefore we have a quadratic equation, which makes a beautiful parabola like we have right here. There are not a lot of good ways to get information, again, just by looking at the equation, but X and Y tables. X and Y tables can be used to graph every single last thing on the planet. And so what I'm going to do right now is I'm going to take a peek. I can create a table with this, with my Inspire. T for table, so Control T. And it'll give me a split screen that will give me my X's and my Y's for my graph. And I'm going to take a look at a few of these things. Can I navigate? I can. There we go. So, couple of things. We're looking at, I'm making myself a little XY table here in my paper. I'll come back to it and show you in a second. -2, -12. I probably won't graph a point that low, but I'm gonna jot it down anyways. At -1, I'm at -6. At 0, I'm at -2. Well, that's a little bit weird because at 1, I'm at a height of 0, but at 2, I'm also at a height of 0. I wonder why that is. I shall have to ponder that more in my life here in a moment. 3's at -2. You want to guess what 4 is? Look at the symmetry. In the y values, -6, -2, 0, 0, -2. This next one's going to be, survey says, -6. So 4, -6. So this is what the calculator is doing. It's just saying, hey, I'm going to plug in values into your equation. So I'm going to plug in 0. It would equal -2. I'm going to plug in 1. It's going to equal 0. So this can be a nice handy way to kind of keep things from having small calculation errors. But ultimately, you really, really want to understand what you are looking at. So back to my paper here for a second. Again, these are points that I pulled off of the table, and that I would like to use those for graphing purposes. However, I have a small conundrum. Because there is a very important point when I'm graphing a quadratic equation. That very important point is called the vertex. The vertex. And that vertex occurs exactly in the middle of a very symmetrical graph. And the problem is I don't have something that's exactly in the middle. I have 1, 0, I have 2, 0. I don't know what's happening in the middle between those two. Well, if we go back to our standard form, here's one of the few things that you can get off of this, and it's not often pretty, but it's often very useful, especially for application problems. If I have standard form and I need the vertex, the first coordinate for the ordered pair is opposite of b over 2a. Opposite of b over 2a gets you your x coordinate for your vertex, which is a very important point. Your second value, well, how did we get these? Plug in -2, get -12. Plug in -1, get -6. Plug in this number, whatever it is, and that gets you your y value. So I'm going to write, so that you remember, plug it in. So this is what I want to use often to give me a feeling for my vertex location when I am in standard form. And I can kind of use that with what I've got going on here even. So opposite of b over 2a. So a, b, c, a, b, c. Opposite of b, well, that's the 3, so -3. So for this one, the vertex is going to be -3 over 2 times a. My a is a -1. The a is the number in front of the x squared. So 2 times -1 is -2. So I know that my vertex is going to be something with -3 over -2. That's 3/2, or 1.5. I'll put 1.5 because a lot of people are more comfortable with that. I'd like to know what's happening there. Can I ask my calculator that question? Yeah, actually I can. Again, jumping back over here for a second. If you work with your table settings, so we have the table boxes highlighted right now. If we go to menu, everything fun and exciting is in the menu, and we can go to our table and say that we would like to, let's select table here, we would like to edit our table settings, change our table settings. Right now it's starting at 0. I'm okay with it starting at 0, but it says it's counting by ones. And if I have a vertex at 1.5, maybe I would like this to count by halves instead. So I can change that if I want. Now check this out. All right, so we're talking moving through here. Oh, now look at my symmetry here. All right, it's -0.750. We can see that at 1.5, we're at a height of 0.25, or 1/4. That is directly between these 2 points. That is my vertex. And so the positive 1.5 actually works for us here. And I'm going to bring this screen back, and there we go. All right. And so I know that this is my vertex. So I'm going to call this the most important point on my graph, and everything else just kind of falls into place from there. So opposite of b over 2a, plug that in, that gets us the other coordinate. Because this is mostly negative, I'm going to start my graph up awful high here. And this is going to be my x-axis. And looking at my values, I'm going to put my y-axis here, I think. I often look at my x and y values before choosing where to put my graph. That helps me figure out where to put my axes. And I'm going to count by ones here because I think I can. -2, -12. Like I said, I didn't think I was going to use that point, but I wrote it down. -1, -6. 1, 2, 3, 4, 5, 6. That's a good point right there. 0, -2. Boom. 1, 0. 2, 0. 3, -2. Again, notice the symmetry. We can see the symmetry here. And at 4, we are at -6. Where's my vertex? 1.5. 1/4. That's it. That's the center. And everything else is symmetrical from there. So this line here at x equals 1.5 is going to be our line of symmetry. And if I'm very careful, I'm nervous here drawing this. Careful, careful, careful. I can always erase it and fix it. Why am I being so careful? Because if I'm not careful, what does the graph represent? Do you know? The graph represents every single ordered pair that makes the statement true. This graph shows the millions and millions of correct answers that go with this particular equation. So if my graph is off, I now have millions and millions of incorrect answers. I don't really want that. So notice I kept the ends of my graph tight. I kept them close to my last point because I know my next one's going to be down here at 12, and so I don't want to do some crazy tail coming off the end of this. This is going to be going down to -12. I want to keep it nice and close so that I don't just make any, I don't know, wild and crazy endings to my parabola. It's not like a story. You don't get to make up the ending. That, ladies and gentlemen, is a delightful parabola. I recommend highly that if you're graphing that you have at least 5 points. Occasionally you can get away with 3, but you want to have the vertex usually and then 2 points on each side at least to get that thing going so you know what it looks like. Alright, so again, that's standard form. That's an XY table. You can use an XY table to graph anything on this planet. What does this mean, though, if we introduce transformations? We can still use the calculator and get points, but I really want you to understand what we are seeing here. So I'm introducing a second form. Also getting out a party zone here, decorating it. This is a very useful form. This tells us a lot simply by looking at it. So this is vertex form for a quadratic equation. F of x equals a times x minus h squared plus k, and the x minus h is in parentheses as a quantity. If you've been working with transformations, because I've been working a lot with transformations, you should know what each of these pieces does. Yeah? No? Maybe? A is in charge of stretches, kind of abbreviating and squishing here, so I'll read it for you. Stretches, compressions, and reflections. Alright, so that is super squishy, but stretches, compressions, and reflections, that's A's job. H's job, we'll put it here. Notice H is in with the X. H is affecting the X. That's going to control a horizontal movement, a slide left or right. So left and right is controlled by the H. And K is on the end. We're tacking it on to our Y values. So this is going to change my Y values. This is a vertical change, up versus down. Alright, so hopefully that's reviewed because I'm not going into that in detail right now. I'm hoping you have some prior knowledge on that subject. I want to use this knowledge to understand where this is going. Before I ever touch a calculator, before I touch a graph, I want to look at this and have a picture in my mind. I want to know where this thing is going. If this is left and right, this is x minus 1. Because we are changing x, but we are looking at it from y's perspective, everything that happens here is a little bit weird. So x minus 1 is actually taking us to the right by 1 unit. Alright, so that right there means we're going to the right 1 unit because we're changing x, but we're doing it from y's perspective, so it's a little bit interesting looking here. The 2, that's my k, that controls the up and down. Well, that's going to be completely as is. Vertical change is a y change, we're tacking on 2. This means that the graph is going to go up 2. Because my a value here is a 1, so if you didn't see an a value there, it's going to be 1. That means it's just a regular old 1. It's not going to be negative, so there's no reflections, and we're not going to do anything crazy for stretching or compressing it either. So this is my basic movement. If the parent function is at the origin, if the parent function has the vertex on 0, and I take 0 and I move it to the right 1 and up 2, without putting anything in my calculator, I want to be able to look at this and say, I'm going to the right 1, I'm going up 2, this is where my vertex should be. So notice HK 1, 2, 1, 2. And I know that I'm going to want more specific points, obviously, but for a little baby sketch, this is what I want in my brain before I push any buttons, because I want to know what's happening and understand what is happening. So that's what we've got here. Again, that's just a sketch. If you are graphing, you should have 4 more points for that. So what is this one doing? Well, if that was x minus 1 was going to the right, guess what this is doing? 2 guesses. I don't know, were you right? Maybe you were right. This one, honestly, pause the graph right now, pause the video right now, and estimate for yourself, all right? So pause and think, go. Did you pause? I hope you paused. What did you come up with? Which way are we moving? Plus 3 is a change to the x, so that's a horizontal change. It's a left-right thing, but it's plus, so we're actually going to the left. I know, crazy. And then minus 4. This is my k, this is my change to my y value, and because it's negative, we will be going down. So this is going down 4. So again, without anything else, graphing with the calculator, I want to have an image in my brain. My vertex was at the origin, parent function is at the origin, going left 3 and down 4. So my little sketchy thing here, left 3, 1, 2, 3, 1, 2, 3, 4. I called it sketchy. Left 3, down 4. That puts us here. And again, I don't have any negative a values there. My a value is just 1. So when I sketch it, I know it's going to look like this. And I'm just looking for 4 more points, 2 on each side, to get that thing going. So vertex form is terribly handy because the h and k control left and right, and therefore the h and k give us the vertex for each of the graphs. Now, I have these two specific for a second here, so I'm going to do this because I want you to focus on these two. I set them up specifically side by side because I really need you to see something. This is very difficult for people. This is A, but one of them is in the parentheses and one is not. And this is where life gets interesting for a lot of people because these do not show the same movement. With this 4 is being multiplied times the x squared. So we are saying with this thing, for x squared, we've got, sorry, my brain toasted out for a second there. Whatever's coming out of this function, we're going to multiply it times 4. Well, what comes out of functions? Y values. And we're multiplying the y values times 4. Y values go up and down. This is a vertical, because it's up and down, vertical stretch. And that is by a factor of 4. Vertical stretch by a factor of 4. Okay, how you doing? This is not a vertical stretch by a factor of 4. All right? This is in the parentheses with the x. This is not affecting the outcome, so to speak. This is affecting the income, the x value. So first of all, this is not vertical at all, it's horizontal. And we can tell because of the parentheses. Can these get really crazy really fast? Yes, the parentheses are meant to help you identify them. Is this still a stretch? Believe it or not, no. And if you go back over here, we said that this is -1, but we're going to the right because we're looking at x from y's perspective, so everything's reversed. This was +3, we went to the left. Everything's reversed. We're looking at it from y's perspective. This is the same thing. We're changing x, but we're looking at it from y's perspective. So this is actually a compression by a factor of, you want to guess? Anyone? Want to guess? Let me show you something real quick. I'm going to take this equation. I'm going to call this y instead of j of x. I'm going to call this y is equal to 4x squared. This is looking at it from y's perspective. I want to look at it from x's perspective. I want to rearrange this. So I'm going to take the square root of both sides. So there's the square root of y equals 4x. And then I'm going to divide both sides by 4. So this is going to become 1/4 times the square root of y equals x. What looked like multiplying times 4, when I look at it from x's perspective, is not a 4 at all. It's a 1/4. So again, because we are changing x, but we are doing it from y's perspective, a 4 for a horizontal change is actually a factor of 1/4. It's actually a compression instead. It gets better the more you see of these things. Again, if you are graphing, 5 points, I would highly recommend it. The calculator can help you with the XY table, but it is really useful to understand what you are seeing, especially with the vertex form. So play with that. Try a couple things out and see what you think. Thanks.